To determine the appropriate feed and fuse size for equipment with both continuous and intermittent loads, treat the equipment as a single unit from the customer's perspective and calculate the total load as 125% of the sum of all continuous and intermittent loads. This approach ensures adequate capacity for all components. The continuous loads are defined as those operating for 3 hours or more at a time. These include the heating, ventilation, and air conditioning systems, the power converter, and the heating coil. The intermittent loads are those that do not operate continuously for 3 hours or more. The calculation involves first determining the full load amperage, or FLA, of each continuous load. The formula for this is FLA equals kilowatts divided by the product of volts and power factor. In this case, the voltage is 480 volts. For industrial loads, a power factor of 0.8 is a reasonable assumption if the actual power factor is unknown. Once the FLA of each continuous load is determined, sum those values together. This sum is then multiplied by 1.25 to account for the 125% factor applied to continuous loads. Next, determine the FLA of each intermittent load. Add the FLA of all intermittent loads together. Finally, add the result of the continuous load calculation to the result of the intermittent load calculation to get the total FLA for the entire piece of equipment. To determine the wire size amperage, or WSA, multiply the total FLA by 1.25 for an additional 25% safety margin. This WSA value should be used to select the appropriate wire size and overcurrent protection, such as fuses or breakers, for the equipment feed. Considering the continuous loads at 125% and the intermittent loads at 100%, then summing them provides the total load. Firstly, determine the power in kilowatts, volts, and the power factor of the loads to be considered. Secondly, using the formula FLA equals kilowatts divided by the product of volts and power factor, the individual full load amperages of the continuous loads are found. Thirdly, add all of the FLA of the continuous loads together. The result of this addition should then be multiplied by 1.25. Fourthly, find the FLA of the intermittent loads. Fifthly, after all of the FLA of the intermittent loads are found, add them together. Finally, add the sum of the intermittent loads FLA to the product of the 1.25 multiplied by the continuous loads FLA. The final result is the total load. This number should then be multiplied by 1.25 to find the wire size amperage. This ensures a 25% safety margin. When dealing with electrical calculations, it's important to adhere to the National Electrical Code, or NEC. Article 220 covers branch circuit, feeder, and service calculations. Section 220.18 addresses the requirements for calculating continuous and non-continuous loads. Continuous loads, as defined by the NEC, are those where the maximum current is expected to continue for 3 hours or more. For continuous loads, the overcurrent protection device and conductors must be rated for not less than 125% of the continuous load. For non-continuous loads, the conductors and overcurrent protection device are sized at 100% of the load. In this scenario, the HVAC systems, the power converter, and the heating coil are all considered continuous loads, while the intermittent motors are non-continuous loads. Understanding the difference between continuous and non-continuous loads is critical for accurate load calculations and proper equipment sizing. The NEC provides specific guidelines for calculating these loads to ensure safety and prevent overloading. In the equipment scenario, the 480-volt feed to the breaker panel supplies several different types of loads. Firstly, there is a transformer loaded with both continuous and intermittent loads. Secondly, there are intermittent motors. Thirdly, there are 2 heating, ventilation, and air conditioning systems, both considered continuous. Fourthly, there is a power converter which is continuous. Fifthly, there is a heating coil. All of these loads contribute to the total load on the 480-volt feed. To determine the appropriate size for the feed and the fuse, it's important to calculate the total load accurately. Understanding how to treat continuous and intermittent loads differently is key to this calculation. If the customer views this as a single piece of equipment, it simplifies the load calculation process. Treating it as a single piece allows for the application of the 125% rule to the total load, encompassing both continuous and intermittent components. This method ensures that the entire system is adequately protected. If the equipment was not seen as a single piece, the calculation would involve separately accounting for the continuous and intermittent loads, applying the 125% factor only to the continuous loads. Therefore, the perspective of the customer is relevant to the calculation approach. When calculating the total load, the full load amperage, or FLA, is a crucial value. It represents the amount of current the equipment draws under normal operating conditions at its rated voltage and horsepower. To find the FLA, divide the power in kilowatts by the product of the voltage and the power factor. If the power factor is unknown, 0.8 can be assumed for industrial loads. Once the FLA for each load is determined, apply the 125% factor to the continuous loads, sum the intermittent loads, and add them together to find the total FLA. Finally, multiply this result by 1.25 to find the wire size amperage, or WSA. This value provides a safety margin and ensures that the conductors are adequately sized to handle the load. Using this approach, the customer can be provided with an appropriately sized feed and fuse. Proper sizing of the feed and fuse is essential for safety and reliability. An undersized feed can lead to overheating and potential fire hazards, while an oversized feed can result in unnecessary costs. The 125% rule for continuous loads is a critical aspect of electrical safety. It ensures that conductors and overcurrent protection devices are capable of handling the sustained current draw of continuous loads without overheating or tripping. The 25% safety margin incorporated into the wire size amperage, or WSA, calculation provides an additional layer of protection against unforeseen fluctuations in the load. By following these guidelines and applying the appropriate calculations, the customer can ensure that their equipment is properly powered and protected. Remember that consulting with a qualified electrician or electrical engineer is always recommended for complex electrical installations or if there are any uncertainties about the load calculations. A professional can assess the specific requirements of the equipment and ensure that the electrical system is installed safely and in compliance with all applicable codes and regulations. The total load is the combined electrical demand of all the equipment connected to the power source. It's essential to calculate this total accurately to ensure the electrical system can handle the load safely and efficiently. When dealing with a mix of continuous and intermittent loads, it's crucial to distinguish between them because they are treated differently in electrical calculations. Continuous loads, like the heating, ventilation, and air conditioning systems, power converter, and heating coil, are expected to operate for extended periods, typically 3 hours or more. Intermittent loads, like the intermittent motors, operate for shorter durations with periods of inactivity. The 125% rule is a fundamental principle in electrical calculations, particularly for continuous loads. It mandates that the overcurrent protection devices and conductors must be rated for at least 125% of the continuous load current. This rule helps prevent overheating and potential fire hazards due to sustained high current draw. To calculate the total load, the individual loads must be expressed in the same units. Typically, electrical loads are expressed in terms of power, such as kilowatts, or current, such as amperes. If the loads are given in different units, they must be converted to a common unit before they can be added together. The power factor is an important consideration in alternating current, or AC, circuits. It represents the ratio of real power, measured in kilowatts, to apparent power, measured in kilovolt amperes. The power factor can range from 0 to 1, with 1 representing a purely resistive load. In industrial settings, a power factor of 0.8 is often assumed as a reasonable average. If the actual power factor is known, it should be used in the calculations for greater accuracy. The full load amperage, or FLA, is the current drawn by a motor or other electrical equipment when operating at its rated voltage and horsepower. This value is crucial for sizing conductors, overcurrent protection devices, and other components of the electrical system. The wire size amperage, or WSA, is the minimum current carrying capacity required for the conductors that supply power to the equipment. This value is determined by multiplying the total FLA by a safety factor, typically 1.25. The safety factor provides a buffer to account for variations in the load and to prevent overheating of the conductors. The overcurrent protection device, such as a fuse or circuit breaker, is designed to protect the electrical system from excessive current flow. The overcurrent protection device should be sized to protect the conductors and equipment from damage due to overloads or short circuits. The NEC provides detailed guidelines for selecting the appropriate overcurrent protection device based on the conductor size and the characteristics of the load. It is essential to consult the NEC and other relevant standards to ensure that the electrical system is designed and installed safely and in compliance with all applicable regulations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years and provides detailed guidelines for all aspects of electrical installations. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Understanding the key concepts and principles of electrical calculations is crucial for anyone working with electrical equipment or systems. By following the guidelines outlined in the NEC and applying the appropriate calculations, it is possible to design and install electrical systems that are safe, efficient, and reliable. When calculating electrical loads, it is important to consider all sources of power consumption, including lighting, heating, ventilation, air conditioning, and other equipment. This is also important to account for any future expansion or changes in the load. Overestimating the load is generally preferable to underestimating it, as it provides a safety margin and allows for future growth. However, it is also important to avoid oversizing the conductors and overcurrent protection devices, as this can lead to unnecessary costs and reduced efficiency. When selecting conductors, it is important to consider not only the current carrying capacity but also the voltage drop. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop to ensure that equipment receives adequate voltage. In addition to the NEC, there may be other applicable standards and regulations that must be followed, depending on the location and type of installation. It is important to consult with local authorities and qualified professionals to ensure compliance with all applicable requirements. The electrical system should be inspected and tested regularly to ensure that it is operating safely and efficiently. Regular maintenance and testing can help identify potential problems before they become serious and prevent costly repairs. It is also important to keep accurate records of all electrical work, including load calculations, wiring diagrams, and equipment specifications. These records can be valuable for troubleshooting and future maintenance.